Like any star, it will run out of fuel in its core, and it starts changing. It starts bloating and getting so large.
Imagine witnessing a cosmic explosion so powerful it outshines our entire galaxy, appearing as bright as the moon, allowing you to read a book at midnight without any artificial light. This isn't science fiction, it's the spectacular fate awaiting Betelgeuse, the red supergiant star that sits on Orion's shoulder. For the first time in over 400 years, humanity stands on the precipice of observing a naked-eye supernova. A celestial event of such magnificence, it will be etched into human history forever. Betelgeuse is no ordinary star. Located approximately 600 light-years from Earth, this cosmic titan dwarfs our Sun in every conceivable way. If placed at the center of our solar system, Betelgeuse would engulf Mercury, Venus, Earth, Mars, and even extend beyond Jupiter's orbit. We're talking about a stellar behemoth roughly 950 times larger than our Sun, pumping out between 7,500 to 14,000 times more energy. This cosmic furnace was born with over 15 times the mass of our Sun, and unlike our 4.6 billion-year-old Sun that's merely middle-aged, Betelgeuse is a cosmic youngster at just 10 million years old. But here's the twist: despite its youth, Betelgeuse is already dying. This stellar giant has lived fast and furious, burning through its nuclear fuel at a ferocious pace. And recently, it's been showing signs that something extraordinary might be happening. The Great Dimming. In late 2019, astronomers and stargazers worldwide noticed something alarming. Betelgeuse was fading dramatically. This wasn't just a slight flicker. The star that normally ranks as the 10th brightest in our night sky tumbled down to 21st place. For months, the astronomy community buzzed with speculation. Could this be the prelude to a supernova? As it turned out, the Great Dimming wasn't the star's final gasp, but rather a cosmic dust cloud ejected from the star itself, essentially a stellar sneeze. Yet this event highlighted an important reality. Betelgeuse is unstable, pulsating, and nearing the end of its stellar life cycle. Think about this for a moment. The light we see from Betelgeuse today began its journey to Earth around 600 years ago. If Betelgeuse exploded any time within the last 6 centuries, we wouldn't know it yet. The light from that cataclysmic event could be racing toward us right now, set to arrive tomorrow, next week, or decades from now. The anatomy of a stellar death. What exactly happens when a star like Betelgeuse goes supernova? It's a process both violent and beautiful. Every star exists in a delicate balance between gravity pulling inward and the outward pressure generated by nuclear fusion. When a massive star like Betelgeuse exhausts its hydrogen fuel, it begins fusing heavier elements: helium, carbon, oxygen, silicon, in a desperate attempt to maintain equilibrium. This process continues until it reaches iron, which becomes the star's undoing. Unlike lighter elements, fusing iron consumes energy rather than producing it. When the core becomes predominantly iron, fusion ceases, and within a fraction of a second, the star's core collapses. We're talking about a sphere larger than Earth imploding at nearly a quarter of the speed of light. The core's temperature soars to billions of degrees, and something extraordinary happens. The collapsing material rebounds, creating a shockwave of unimaginable force. This is when the real fireworks begin. That shockwave tears through the star's outer layers, generating a supernova explosion that can briefly outshine an entire galaxy of 100 billion stars. In just 10 seconds, the supernova releases approximately 10% of the star's rest mass as energy, producing around 10 to the 46th power joules and a 10-second burst of neutrinos. 2 possible fates. Depending on Betelgeuse's exact mass, 2 scenarios await this stellar giant. If its mass is on the lower end of red supergiants, around 10 to 15 solar masses, the star will collapse into a neutron star and produce a brilliant supernova. But if Betelgeuse is closer to 20+ solar masses, the gravitational collapse might be too intense, even for neutrons to resist. In this case, Betelgeuse could collapse directly into a black hole, possibly without a visible explosion. The star would simply vanish from our night sky. The coming light show. If Betelgeuse does explode as a supernova, what will we see from Earth? The spectacle will be unlike anything in recorded human history. When the light from Betelgeuse's explosion reaches Earth, the star will brighten dramatically over hours or days. At its peak, the supernova could shine as brightly as the full moon, except concentrated in a single point. For comparison, the 2015 supernova ASASSN 15LH reached a luminosity of around 2 × 10 to the 38th watts, the combined output of 500 billion suns. But that explosion occurred in another galaxy. Betelgeuse is in our cosmic backyard. For weeks, possibly months, this supernova will dominate our night sky, visible even during daylight hours. At night, it would cast shadows and provide enough light to read by. Humanity hasn't witnessed such a cosmic spectacle since Kepler's supernova in 1604, which occurred before the invention of the telescope. The mystery of Betelgeuse's rotation. One of the most puzzling aspects of Betelgeuse is its unusually rapid rotation. Recent measurements using the ALMA array revealed that Betelgeuse rotates about once every 20 years, with its surface moving at roughly 18,000 kilometers per hour, 5 kilometers per second. This is far faster than expected for a red supergiant. How did Betelgeuse achieve this rapid spin? One compelling theory suggests stellar cannibalism. Betelgeuse may have engulfed a smaller companion star, gaining both mass and angular momentum. The evidence includes nitrogen-rich outer layers and unexpected internal mixing. However, a recent study proposes an alternative explanation. Perhaps Betelgeuse isn't spinning unusually fast at all. The apparent rotation might actually be an illusion created by the star's violently boiling surface. Betelgeuse's turbulent atmosphere contains convection cells, essentially bubbles of hot gas, some as large as our entire solar system. These massive bubbles rise and fall at speeds up to 67,000 miles per hour, 30 kilometers per second, potentially creating patterns that mimic rotation when observed from Earth. Betelbuddy, the hidden companion. But wait, there's another twist in this stellar saga. Recent analysis of Betelgeuse's brightness variations has led some astronomers to propose that it might have a companion star. This hypothetical partner, playfully nicknamed Betelbuddy by researchers, could be about 1.7 times the mass of our Sun. Computer simulations suggest that this companion might be responsible for Betelgeuse's pulsation patterns, particularly its 2,170-day cycle of dimming and brightening. Like a hidden hand tugging at the giant star, Betelbuddy could be influencing Betelgeuse's behavior in ways we're just beginning to understand. If confirmed, this companion star might significantly alter our predictions about Betelgeuse's future. Binary star systems can behave quite differently from isolated stars, potentially extending Betelgeuse's lifespan and changing how and when it will eventually explode. When will it happen? This is the million-star question. When will we witness this extraordinary cosmic event? According to current estimates, Betelgeuse could explode any time within the next 100,000 years. That's an extremely short time frame in astronomical terms, but potentially a very long wait by human standards. Yet there's that tantalizing possibility. Given the 600-year light travel time, Betelgeuse may have already exploded, and we're simply waiting for the light to reach us. The supernova that will captivate future generations may already be racing toward Earth at the speed of light. Is Earth in danger? Fortunately, at 600 light-years away, Betelgeuse sits well beyond the danger zone for a supernova, estimated to be around 50 to 100 light-years. While the explosion will provide an unprecedented celestial light show, it poses no threat to Earth or its inhabitants. The supernova might have minor effects on our upper atmosphere, potentially creating spectacular auroras, but nothing catastrophic. We'll get all the spectacle with none of the hazards. Scientific goldmine. For astronomers, a Betelgeuse supernova would be the opportunity of many lifetimes. Never before have we had the chance to observe a nearby supernova with modern instruments. The wealth of data gathered would revolutionize our understanding of stellar evolution, element formation, and cosmic cycles. Every atom of calcium in your bones, the iron in your blood, the gold in jewelry, all were created in the heart of exploding stars like Betelgeuse. Observing this process up close would provide unprecedented insights into the cosmic forces that created the elements necessary for life itself. Cosmic perspective. In the grand scheme of cosmic time, we're extraordinarily fortunate to exist at a moment when we might witness this spectacular stellar death. Modern humans have existed for roughly 300,000 years, while Betelgeuse's supernova window is perhaps 100,000 years. The odds of our species being around to see it are remarkably good. Whether Betelgeuse explodes tomorrow or millennia from now, its story reminds us of a profound truth. Stars, like all things in the universe, live and die. Our sun will also meet its end someday, though as a less massive star, it will fade rather than explode. So next time you look up at Orion on a clear night, take a moment to appreciate that distinctive reddish star on the hunter's shoulder. That crimson glow comes from a dying stellar giant, one that might, within our lifetime or that of our distant descendants, treat humanity to the most spectacular light show in recorded history. A supernova so bright it will temporarily outshine the combined light of billions of stars in our galaxy. The universe is putting on a show, and we all have front-row seats. Betelgeuse stands as a cosmic time bomb ticking away in our night sky. Its inevitable explosion will not only illuminate our world, but also our understanding of the universe. This red supergiant continues to challenge our theories about stellar evolution and behavior, from its unusual rotation to its potential hidden companion. When Betelgeuse finally detonates in its spectacular supernova, it will bridge ancient and modern astronomy. Just as our ancestors gazed up at Kepler's supernova in 1604, future generations may stand in awe of Betelgeuse's final brilliant performance. In that moment, as a single star temporarily outshines a galaxy of billions, we'll be reminded of the awesome power and beauty of our dynamic cosmos. It will be the astronomical event of our age, a fleeting glimpse of cosmic mortality that reminds us of the constant cycle of stellar birth, life and death that ultimately made our existence possible. What are your views on this? Drop down in the comments and subscribe for more.